Great. All right. Hello, everybody. Hope you can hear me and see my slides. My name is Kate Cahill, and I'm at the New Jersey Institute of Technology. And thank you for joining us for our the first of our webinar series. So along with my partners on our project, I'd like to welcome you to the opening of this webinar series on computational and data science curriculum development. And so I want to give you some introduction to our project, which is the Computational and Data Science Exchange. And I hope that overall in this webinar, you can take away some important ideas about the computational and data science curriculum, and as well as some useful resources that I'll share on some tools for teaching computational and data science in the classroom, and hopefully some motivation for adding these resources to courses you're teaching or ideas for future courses. Okay, there we go. And so we are, our project is focused on computational and data science curriculum development. So, we believe, and we think it's generally accepted, that learning these kinds of computational tools is essential for students going into the workforce today. So, these are used across many domains and in many areas of business and research and sciences. And so learning these skills is useful both to be able to make use of these tools, but also to understand how they're being used, in projects you may be working on, just understanding, what the principles are of modeling. And that computational and data science has become an essential part of the design and discovery process across many fields. And so, these models have become increasingly complex, and there are very, advanced tools for doing, a lot of these models, but the underlying concepts are still relevant and can be taught with simple tools. And we know that a lot of institutions have made courses and certificate and, major and minor programs available for computational and data science over the years, acknowledging their importance to training for research and other types of work. But we know that there are still barriers for some institutions and some instructors to add these materials to their courses and to develop larger programs in their institutions. And those barriers can be time and resources at the instructor level, expertise and comfort with these tools, as well as administration buy-in and interest in really expanding in this area. And so we know that leads some institutions, particularly under-resourced or teaching intensive institutions, are not adding these resources to their courses and giving their students these opportunities because there are these barriers. And so we're hoping that this project can provide some pathways to add computational and data science modules to courses, and hopefully courses and programs to at these institutions. So the goals of our project are one, to build community. So create a network of educators, researchers, and practitioners who are passionate about computational and data science education. Just kind of be able to have a place where people who are interested in this topic can meet and discuss ideas and share expertise. And then we also want to be able to share educational resources. So, we have some existing course materials from our pilot project that we developed that we can share, and, thoughts about tools and other resources. And then, so we want to make those available and have a platform for sharing those for, our community. And then we also want to facilitate creation of course materials. So developing new materials by faculty within the project, as well as facilitating other members of the community to develop materials in our project activities. And then more generally provide support to faculty who are interested in computational and data science, to provide them with professional growth opportunities and support that they may not have at their institution because they may be a lone member, a lone person who's interested in these types of skills and adding these materials to courses. So we want to provide that support and expertise for faculty as well. And so here are our project partners. So the Computational and Data Science Exchange, we call the CDS Exchange. These are the partners in our current project, most of whom were also part of our pilot program. So I'm at the New Jersey Institute of Technology, and I'm focused on curriculum development, building, and education programs. Linda Ackley is at the Texas Advanced Computing Center, focused on broadening participation. Dina Tandabani is at Clark Atlanta University, and he's a chemistry instructor. Rachel Vincent Finley is at Southern University Baton Rouge and is math professor as well as associate dean. Karen Rios Soto is at the University of Puerto Rico Mayagüez, and is also in the mathematics department. Alam Tenori is at Morgan State University and is also a mathematics instructor. And Lizanne DeStefano at Georgia Institute of Technology is our evaluator. And Vitria Bird at Purdue University is our visualization expert. And so the expertise that we have here amongst these faculty, they have all worked on developing computational and data science course material in different domains. We can share that expertise across the project and fulfill different types of computational and data science needs. And so, our goal is to bring all that experience together into this community. So providing the faculty community, materials, expertise, and development opportunities through our webinars, our materials repository, regional workshops that the faculty at the different institutions will hold workshops for their regions. We'll also have a national fellows program, so that'll be a virtual fellows program for anybody in the country to apply to. And then we'll also have an annual symposium where we can bring the community together to share experiences and materials that have been developed. And so we hope that these, bringing all these project partners together into this faculty and providing this support will lead to impacts both for institutions and departments as far as adding materials to courses, creating new courses, creating certificate programs, and then that will lead to more students getting a chance to learn these skills, which will then bring them into the computational and data science community, where they can have the opportunity to do internships, programs like the Match program from Access, research experiences, and just computational research as well. So hopefully getting more students to do this type of research. And so we believe in the importance of these skills, and that they can be very effectively taught in the classroom, but they also bring other skills with them. So teaching computational science isn't just about teaching coding and using a computer. It's also has a lot of underlying skills that are really key as well, that when taught in a project-based format, the students get really a whole host of skills that are really useful. So that includes data management skills, so being able to work with data, clean data, transfer data to different places, and just being able to use the technical skills to manage data. And then analytical skills as well. So being able to analyze a model, understand its components, and what information you can get from it, and be able to understand the output. And then also teamwork skills, being project-based often, A lot of teamwork skills goes into being successful in computational science. And then communication skills goes along with that, both communicating within your team, because often you have people with different backgrounds from different domains working together on a project. So communication that way, as also communication of the results of your work through presentation, poster writing, paper writing. And so, all those skills that are important for research. And so we want to focus the type of curriculum development on inquiry-based education. Because that we find, engages students more effectively when they can take a problem that they're, interested in. And often you can get students to come with, ideas for problems to work on that they're already interested in, and help them use the tools to solve that problem. So it really gets past the interest issue if the students have already become interested in a problem, and you can show them tools to help work on it and learn more about it. And so to acquire, so there's a whole process of appropriate skills to acquire when working with models. And you can begin with basic skills about, understanding the building blocks of computational models without working with a computer at all. So you don't have to start with coding. You can start with the basic idea of how to turn any kind of physical system into a model. And so what are the steps? What are the things you have to understand about the system? How can you break it down into smaller steps? And what are the relationships that make up that system? And so you can do all that without thinking about, coding or anything yet. And then you can start to, understand more about the system just from that process, and then start defining those relationships in mathematical terms and being able to do a more analytical approach, and then bring it over to the computer and how can we implement this model and what are the tools available. And then the next step would be how to test whether your model is right. So what are some verification tools that are available? And so I have on the right these steps. So this is kind of breaking down the modeling process into these steps. But this is also a process of kind of understanding any system. You can use a layout like this and to define the connections and the steps you would have to take to understand a system better. And so when you're working on, in introducing students to these skills, you can start with existing models that have already been built, and you can use examples that are specific to your domain or discipline, and investigate how those models have been used to gain insights about systems that are otherwise fairly complex. And so there are many examples of built models you can work with to show students what can be done, and how these models actually capture some key concepts. And then the next step would be to take an existing model and add some components to it, or think about how you could make it more complicated, or add some features that would give you more insight. And so how would you do that? And then you can work up to building new models of systems of interest, and figuring out what you can do to explore the system with a model that you can create yourself. And then how do you share those results? So being able to present those, the results and the details of what you did and what you learned from it. And so an example of a built model, or a set of models that you can use that are already built. The University of Colorado at Boulder has a computational modeling resource site with a lot of browser-based models for different scientific concepts. And so these are really easy to use. They're all different disciplines. Some of them are more focused on K through 12, but the concepts can be really complex. And so they're a really good place to kind of show what's possible with model building, and they're just nice to interact with. So the link is here, and I have an example, just a picture of an example here, showing static, the static effects with a balloon and a sweater, and you can manipulate the balloon and see how the charges move around the different pieces. And so they're really fun to work with, and they can be a really nice way to introduce this. And so, once you have, started kind of introducing the ideas of models and what you can learn from models, then you can, have the students progress to using different types of modeling tools. So, learning programming skills, learning more of the math behind models and being able to be more comfortable with the applied math skills. And then specifically focusing, so you could have if you have a course about a specific discipline where you can apply these types of skills to a specific area related to a student's major. And so that's, a way to build a certificate program that has several steps for the students to follow that would be, connected to their larger major. And then the students could also expand the size of the models that they're working on from, laptop scale to larger system scale and supercomputers as well. So they can take advantage of larger, computational capacity and more experience, being comfortable with using large scale computing. And so other work that's been done on these progressions is to make competencies, so a set of competencies for developing certificate programs in computational and data science. And that's linked here at hbcuniversity.org. And this is work that was done as part of the Exceed project to pull together a more cohesive group of skills that would make it easier for somebody to build courses or to build programs in these areas. And so you can start with very simple tools. It isn't required that you start, with a coding, something very technical. To illustrate some modeling principles and simple systems, you can use tools like Excel. So we have some Excel examples where it's just a built, Excel file, and you can do modeling such as population change. So looking at a simple idea of you have a population, you apply some change to it, and then, what is the result? And, iterating over that and using the Excel tools to have, a visualization of that and an output. And you can, have the students break down kind of the pieces of the model and how it's calculating, how it's showing this change over time, and what are the inputs, and how do you, what happens when you change those. So that's all just in an Excel file. And the same thing you can do with the diffusion model. So Excel is great because you can, copy the calculation over many cells and then, make some change and see that calculation kind of iterate all over those cells. And in the case of this file, for this diffusion model, you can use conditional formatting to change the colors. So you have a visualization element as well. So just using, a simple tool that the students would be fairly comfortable with to start with Excel, and showing, some models that can have a lot of different features in them. And so then there's a link here for some other examples of Excel tools. So another type of modeling that can be useful in different domains is network analysis. So this is done a lot when looking at different social media networks, and because then you can get a lot of data about, who is sharing information and who's receiving it, and what discussions are happening. And so you can look at that as a network, and it can give you some insights into who is leading discussions. What are the key ideas? Is there a change over time? What are the subgroups bring, to the overall discussion? And, how do these relationships, strengthen or lessen? And so network analysis can be a really interesting way to look at this kind of interaction. And it gives some great visualizations as well. So here's an example of network design. It's a network analysis of 16th and 17th century social networks. And so this is a visualization tool. This was also an Exceed project. So this was done part of the Exceed project's support for research projects, where they helped to build this tool and make it sort of interactive and usable still. So I don't know if I click on this, if you can see it. So let me know. Can you see, I clicked on it. Do you see the visualization? You do.
Yes, we do. Yes, we do.
Great. So this is the network analysis. So this is done using, historical texts, and anything that was saved from the time where people are talking about each other or mentioning something somebody else said. And so this is a fairly extensive network analysis, but the visualization makes it, both impressive, but also something that you can work with and break down. And so you can look at different networks in this whole social grouping and see kind of how people are connected and how closely they might be connected. And you can get more information about, different members of the group. So this, highlights, different parts of the network and who's connected to whom. So it's a nice visualization, and it's nicely interactive, and it gives you a lot of information. And it's easy to show as an example of network analysis. All right. And so moving on from network analysis to another type of modeling, which is systems modeling, which is a way of looking at a system and analyzing the behavior of that system. And this can be done in many different disciplines. So it can be applied to chemistry and physics systems, as well as social systems, historical systems. It's been applied in a lot of different ways. And so you can see, how systems can have complex outcomes, even with fairly simple interactions. And so you can focus on how the different elements of a system are connected. And so this is a really popular type of modeling that has a lot of great examples out there, and is very relevant in a lot of different disciplines. There are a lot of tools that you can look at, different types of systems modeling. So some examples are here. The tool that we work with mostly, because it has a free education version and is fairly robust and easy to use, is Vensim. So you can download Vensim as the education version, and it's completely free, and it's got a great user interface to do systems modeling. So here are two examples of some Vensim models. So on the left, you see this is looking at a population. So this is a population model for bunnies, and there's two different versions of the model. One is looking at the effect of carrying capacity of the environment on the population, and then the lower one is looking at the effect of competition. And so you can just build this really, really easily and just say, so what is the effect of these different inputs on the population in a simulation? And then you have your output graph here, and you can make changes to the inputs. So in the program, these are sliders, and you can change these values, and you'll see the effect on the output immediately. So it's a nice interactive way to test things and see the effect of different changes on your system. And it's really kind of easy for students to get started with Vensim. And then on the right, we have a more complex model. This is looking at drug dosing. So it's looking at the effect of the concentration of a medicine in a body with a certain amount of blood volume, and you're looking for an effective concentration. So you want to see the concentration of the medicine between the medicinal and the toxic levels. And so how can you control dosage and frequency to get the optimal, effective medicinal dosage. And so this is again, it's a interesting problem, definitely has real world impacts, and you can see how, what the effects of different changes on the model will have. So that is nice to work through and think about. And so there are other examples of Vensim models, and probably others elsewhere. But you can look at different domains and try out Vensim in different ways. There's also the Vensim site has tutorial videos too. So if you wanted to look at using Vensim, you could check out the video where they show you how to just start building a simple model. So it's fairly easy to get started. So the last type of modeling I wanted to talk about was agent modeling. So this is another way of sort of abstracting a system into a set of rules that you can implement on a computer. So an agent in this model would be it's an autonomous entity that acts according to a set of rules or constraints. And so you have an agent, and you have to define what that agent is and how it's going to act, and what happens when agents interact. And so you can define multiple agents in a given model and then allow them to interact and see the outcomes. And with agent modeling, you also get randomness into you can add randomness into the interactions. And so that, adds that layer of the randomness of any system can be included in an agent model, without too much complexity, as far as coding and kind of computational complexity. And then the other thing about agents is that they're acting both in time and in space. So you can actually define a space for your model and define spatial characteristics that the agents have to move around in. So you can look at systems with also a spatial component. And so some examples, popular types of agent models, looking at the spread of disease in a spatially explicit way. So you can do spread of disease modeling in systems models as well. But with agent models, you can look at what would the effect of changing something in space have on the different agents. So can you keep agents apart by having different spatial characteristics. Also with agent modeling, you can look at growth of urban areas, supply chain optimization, cell and immune system models, so looking at the movements of compounds and things throughout the cell, other biochemical processes like protein interactions, and then economics models is a very popular area. A lot of agent modeling is done for economics. And so you can think of agent models as having a story where you're defining, your agents, and they have these different features, and what is the story of their interaction. And so you can, build up some idea of what you think the interaction might be like. And this is a good way to, start thinking about your analysis to predict what you think the outcome might be, and then build the model and see, compare it to what you observe. So one of the tools that's nice for agent modeling is NetLogo. So NetLogo has a web version, and then it also has a downloadable software package. And there's a robust community around NetLogo, so people develop new models, and there's models in a lot of different fields and disciplines on NetLogo. So the example I'm showing here is it's a browser-based model of predator-prey. So in this case, we have wolf agents and sheep agents. And you can see on the left, you can, change the parameters of each of those agents and how many are there and what happens when they interact and what is the birth rate for the different agents. And so then when you run your simulation, on the bottom, you see the graph that shows you the change in these populations over time. And so this is a nice way to just quickly put together a predator-prey model and test it and see the outcomes. And so other agent modeling tools that are available. Agent Cubes is a browser-based modeling tool. It's kind of focusing on the game side of agent modeling, but it is an agent model tool, and can you can do similar things. NetLogo, as I said, Star Logo, Repast, and Swarm are you know options that have larger scale versions available as well. And so, I hope that if you haven't used these tools before, that maybe these give you some idea for possible, modeling examples that you could use in courses that maybe you already teach, or that might be relevant to your students for a project. And so these materials are all, available. I have a link here to our project page. This is our project website. And in there, we have a page on this webinar where I have the slides for the webinar, as well as a page of resources. So all the links that I shared in the presentation are on that resource page as well. And so you can always reference that and take a look at those resources. And then also, once we have the recording ready, we'll post the recording on that page as well. And so, this was our first webinar of our longer series. So we're going to have 4 more webinars, and those will be more specifically focused on different areas of computational and data science. So looking more specifically at curriculum that faculty have developed. And they all happen on Fridays at 3 p.m. So the same time as we're meeting today, but obviously they're not, they're not sequential. So next week, we're going to have our data visualization specialist, Vitria Bird, talk about her modules for visualization. And then in April, Ana Gonzalez, retired professor from the University of Puerto Rico at Mayaguez, is going to present her work developing the course Introduction to Modeling and Simulation. In May, we have our first, on May 10th, our first webinar that month will be Matrix Methods for Data Science and Machine Learning from Dr. Alam Tanuri from Morgan State University. And then Dina Tandabani at Clark Atlanta University will present computational chemistry focused resources, talking about using science gateways as classroom resources. And so we hope you'll join us for those webinars. And thank you so much for your attention. And so our general project website is listed here, and we are the CDS Exchange project.
Kate, could you drop the project website in the listserv address into the chat box?
Yep. Maybe.
You might need to get out of presentation mode to do it. I don't know why it's, I've had this issue before.
Sure, yeah, highlighting it doesn't really like that, does it?
Yeah. Was it a Google slide presentation out of curiosity?
Yes. Yep.
Yeah, that would be it.
Here we go.
So any questions at this time? The floor is open.
Oh.
I do have a question. So in the beginning of your webinar, by the way, thank you so much for this. This has been a really great information session. I love the links that you shared. There was a point you had made about teaching the students the models first and how to evaluate the models, and then teaching the science and then teaching the mathematics behind those models. Myself coming from a statistical background, I was kind of taught the opposite. You learn the statistics first and what's the math and then what the models are doing. I was just curious what the motivation was to do it by this approach and the results you've seen by doing it that way.
That's a good point. So it so we find that, students are interested in whatever field, when they're in, we're talking mostly university level students, they already know kind of the field or the area that they're most interested in. And so we found that that introducing them to these models in a more like context of the types of problems that they're already interested in solving kind of gives them more reason to want to learn more about them. So it just kind of engages them more rather than kind of teaching them the underlying knowledge and skills are obviously key to working with these tools, but giving them a reason that you want to learn this because it will help you do the thing you're interested in. And so giving them a context for why it's important really gets them engaged more quickly.
That makes a lot of sense. Thank you. You're using an already existing motivation to then be able to introduce the materials and make them more receptive to them as well. So that's really awesome. Thank you.
Yeah, sure. So sorry, it looks like there's some issue with the link to the Google site. I'll have to update that. So yes, we just started our project, so we haven't worked out all the kinks yet. So thank you for your patience. We have a couple of our project members here. I don't know if any of you want to share anything about your work or your anything about your future webinars.
I think I'm the next one coming up. So, so first, I did post something in the chat and say great job, and I think you gave an excellent overview and introduction to the project. And so, just kind of a preview for next week, I will be talking about data visualization and curriculum building for introducing data viz into existing curriculum, but also sharing resources, much like shared today, about different types of visualization. And so as I was listening to your talk, Kate, I was thinking about the diverse clientele that we have here, diverse participants, everyone having probably different research needs and data visualization needs. And so what I'm going to try to do is to provide something, a little bit of something for everyone. It's going to be, it will start out as a high level introduction to what data visualization is, and then we will look at the different types of visualizations and lots of tools that you can use as resources going forward. So I look forward to presenting next week.
Hey, this is Dina Tandabani. Thanks, Kate. It's very, very nice presentation, very good overview. Some of them are asking for the permission, actually, because it's tied up with the Google. If anything you connect with the Gmail account, it may give the permission. Anyway, I think Kate can able to add you once you request the permission. So then you can have an access for that.
Yeah, we'll get that, that access.
All right, Kate, in the chat, we have a question. Are we able to find some discipline-specific models too, such as business? I saw you had supply chain optimization in your slides, but I am curious if there is guidance to find discipline-specific models that I could use for my course directly. I just think the question is asking, are there some models that models that are already out that he might be able to leverage, the person may be able to leverage to use in their class?
Yeah, so some of the links that I have in the presentation are for a educational resource. So the Shodor organization has developed models in a lot of different domains over the years using the different tools that I mentioned, like Vensim and Excel, and other tool platforms, NetLogo, I think, as well. And so if you follow one of those links that's in the slides, it's like, Shodor Talks New. there will be a very large, a large list of example models for different types of phenomena. I don't know of one, like I don't remember like a specific business focused application, but there are a lot of the kind of, general models that can be, manipulated and kind of maybe, relabeled for different activities. So you could focus it on a system that's relevant to your domain. But yeah, I mean, it's one of those, like we could, look into that and see if there are more business focused models somewhere, like in another resource list.
Thank you. So I'm the one who posed that question. So I've tried to bring all those kind of websites that you introduced in this session, but many of them are related to biochemistry or those kind of areas. So it's a bit hard to find the model that I might be able to use for my class. I think the several one that I might be able to try is the supply chain optimization or the network analysis related thing, but
Right.
there was no link for those supply chain optimization
Sure.
model. So yeah, if you can share those information, I think that would be awesome.
Yeah, like I said, we're going to be building up, a resource list. So we'll, try and like add examples from different domains. So I'll make sure to look into what's out there on the supply chain modeling. And I see Rebecca posted a response as well. Indie SCC.
So the NDSCC, so first off, SCC stands for Student Cluster Competition. So this is a national competition that is typically occurring at the SC or the Supercomputing Conference. The NDSCC specifically is similar to this competition, but it's meant really for students that perhaps need more education on what supercomputers are and how to use them. I participated last year, and for example, they have GROMACS and other, software that can be used on supercomputers, and they provided examples. So not sure about business per se, but just saying that they also might have like some domain specific examples in case anyone's looking for them.
Thank you.
Maybe it's time for me quickly to respond and introduce myself. My name is Alam Tinuri, and I will be presenting, I think, on May 10th. My part would be, I would say based on linear algebra, but I am going to use it to build like machine learning models. And in my days, not long time ago, I supervised a master thesis for students who did work on supply chains. So, and I am developing during the next 3 years of the project, our project, I'm going to be developing models. So this is a good idea. And maybe next summer or the summer after, I can develop a model, and at the same time, we can find resources and we build it. And this is why we have such meetings, because it guides us to develop models, because after all, one of the important objects of our project is to create, units, I would say, models, so to be used in classrooms. So this is a good suggestion. And I don't know, maybe not this summer, the summer after, I will be working on developing something like that.
I also think this might be an opportunity when we think about our fellows program, which will kick off in the fall, where we're going to be inviting people to work with us to develop modules, that this may be one that you might be interested in we could collaboratively build it. And with our expertise and with your understanding of what you would need. So keep your eye out for future announcements. I know Kate mentioned it in the beginning, but we don't have dates or any specifics yet to announce. But this certainly would be very, very appropriate for that.
And we can widen our reach. Is not only for chemistry or biology or science. It's in all domains, engineering as well.
Yeah, so like I said, we are just getting started on this project. So we want to start the webinar series and get this information out and start hearing from people about sort of what you would be interested in and what would help with your education goals and teaching goals. And yeah, and if there are, we're also looking for future webinar presenters. So if you have ideas about experiences you've had or materials that you do teach with in computational or data science area, particularly in, areas outside of the more traditional ones, we would love to have you, come and give a talk for a, future webinar.
So if there's no more questions, we want to thank everybody for attending. We really appreciate you joining us for our inaugural edition of our webinar series. And hopefully some of you all will come back for some of the future topics that we have listed.
Mm-hmm. Yeah, thank you, everyone.
Thank you.
Thank you, Kate. It was a very nice presentation. Thank you.
Thanks.
Thank you.
Thank you.
I'm trying to see how long it'll take to get down to just the project team.
Yeah, we'll send out the
Yes,
recording.
we will send the link out to the people who attended.
And Linda, I can't control the recording. I don't think you may have to.
Oh yeah, I
did.
need to stop it.
Nope, I did.